Hello, welcome to this lesson video for solving for roots by the square root method. So we're going to be taking quadratics and solving them with the square root method to find the roots or to find where the graph crosses the x-axis. So let's begin. I ask us to use GeoGebra, so I've got it fired up on my internet. We'll pull it up in a second. But I say graph this guy and see where does the graph cross the x-axis. So one thing we want to be familiar with, you remember this 0, we're going to replace it with y when we go to GeoGebra. So let's see, x squared minus 1. I can remember that. So let me adjust GeoGebra. All right. So I typed it in, and here's the picture that popped up for our equation. One thing I would like you to notice is here where the graph is crossing the x-axis. So we're crossing when we have an x value of 1, and we're crossing when we have an x value of negative 1. But here's kind of the big picture. Negative 1 and positive 1 is where we cross. How can we prove that, like if I didn't have a graph, just looking at the equation? How could I solve to show that? Well, if I think about the original equation where I have equal to 0, we want to try to get x by itself, so let's see. My first step I would say would be to isolate my x squared. Do that by adding 1 to both sides. Whoops, there we go. Okay, so then I'd have x squared equals a 1, and now I want to get x by itself, so I want to get rid of this power of 2. What gets rid of a square? A square root. So step 2 would be take square root of both sides. Whoop, there we go. So let me change colors. So on the right here, or no, sorry, on the left, a square and a square root just cancel each other, so I have an x. On the left-hand side, though, the square root of 1 is just 1. But remember how we had a positive 1 and a negative 1 crossing the axis? That's because when you're solving and you take the square root, you have to remember that you need the plus or minus sign. And so that's how we can show, the negative root and the positive root. Okay? So there we've proved that the graph does cross at the x-axis at the value of negative 1 and positive 1. So let's keep rolling. I think we've got another equation to plug into GeoGebra. Again, if you're going to use a graphing, you want y to replace 0 with a y. But let me shoot over back to GeoGebra and find out where this guy crosses the x-axis. Okay, so here's our new graph. Let me see. Let's kind of lower this a little bit so you can get a better visual maybe where we cross up there. Okay, but again, I'm not worried about that point on the y-axis. I'm worried about where I cross at the x-axis. Now it looks like I cross somewhere between 1 and 2. Well, it looks like it might be a little bit more than 1.5. And then I do the same thing on the other side. It seems like I cross somewhere between negative 1 and negative 2. It looks like it might be a little bit smaller than negative 1/2 though. So if I go back to our slide, I'm gonna guesstimate, I don't know, seemed like it was a little more than 1/2, so maybe I would say like negative 1.7 and then positive 1.7. This is just a guess from our graph. Okay, so I'll write that. Just a guesstimate. Let's algebraically find the exact value of where we're crossing. So when I take this equation, and I'm going to take the equals 0, again, the first step is to get that x squared alone. Isolate x squared. So to do that, I'm going to subtract 8 from both sides first. I want to undo any addition or subtraction first when we're solving. So I have negative 3x squared equaling a negative 8. Okay, let's see. Then I'm going to divide by negative 3. So then I'm going to have x squared equals, two negatives turn to a positive. So I'm just dealing with the positive 8/3 as the fraction. And second, now that I've got x squared by itself, second step, remember we said to get rid of a square was to take the square root of both sides. Okay, both sides, I should say that. Here's the deal though, we've got a fraction, so you know, technically we're taking the square root of this big fraction, 8/3, but for the sake of time, you know, a property of a radical is that you can break it up, square root of the top number divided by square root of the bottom number, so I'm just going to jump straight to that. So I have x equals square root of 8 divided by square root of 3. But now we've had this discussion before that you're not allowed to have a radical at the bottom of a fraction. That is improper and not mathematically correct. So to get rid of it, remember we rationalize, we use this special fraction where we multiply by square root of 3, top and bottom. And so a couple ways you could look at this. Going across the top, 8 times 3, since they're both under a radical house, you can multiply 8 times 3 and you get radical 24, square root of 24. If you know square root of 3 times itself, you know you drop the house and you just keep the 3, or if you literally multiply 3 times 3, you get square root of 9. But what is the square root of 9? It's just simply 3, okay? Now here, sometimes folks want to divide by 3 and make it square root of 8. However, 24 is under a house, 3 is not. So division, you know, simplifying is not okay here. Rather, what we have to do is factor tree, you know, simplify this radical. So 24 breaks down to a 12 and a 2. This breaks down to a 2 and a 6. And this breaks down to a 2 and a 3. So what am I looking for? I'm looking for pairs here. It's going to take 2 to go out and play. So, let's see. I'm going to end up with, how should I write this? I'll come down here and do a new line. I'm going to end up with a 2 on the outside, coming from the pair 2's that I had. But what has to go back in is the 3 and the 2 multiplied back together to 6, divided by 3. Okay. Now one thing I forgot, because I took a square root while I'm solving, you know, I need plus or minus here. Now, how do we even know what this value is? Because remember our picture, we guessed it being like 1.7 and negative 1.7. Well, let me just type this in my calculator real quick, just to kind of get a decimal value to see if my guess was even close. And hey, not too bad. In my calculator, this turns out to be, you know, roughly, I should put an approximation symbol there, roughly 1.63, obviously the positive and also the negative of that number. So I was close. My 1.7 guess wasn't too bad. But when you're solving, you know, most likely this would be the answer on like an assessment with multiple choice or something. They would leave it in radical form, most likely. And I guess I forgot to do my steps, didn't I? Let's see. Take square root of both sides. We had to rationalize. We had to simplify a radical 2. But then that kind of got us to our final answer. All right, let's check out the next one. Here, we've got a group of parentheses that's being squared. So same thing, they want us to look at GeoGebra. So let's go back to GeoGebra real quick and put this guy in. Okay, so here it is when I plugged it into GeoGebra. You can see that, whoa, wait a second, we don't cross the x-axis at all. So let's go back to our slide here. And it says, where does the graph cross the x-axis? I'm going to say it doesn't. Okay, so I wonder why that's happening. Does the graph have a minimum or maximum? So if I go back to the picture, since it dips down like this, it has a low point. We're going to call this point the maximum. And I know that it asks for the coordinate of that point. So the coordinate is 2, 3. So I have a minimum because it was a low point. And what's the coordinate point for this minimum? 2, 3. So I think I have some more questions. Yeah, show it algebraically well, why our graph doesn't cross the axis. So let's see what happens when we solve this guy. See what's going on with these answers that's making, whoops, I just wrote that wrong. That's making it not cross our axis. So minus 2 squared plus 3 equals 0. So the first step, it's a little different since we have these parentheses. We're not trying to get x squared alone. We're actually trying to get the parentheses squared alone, or isolate the parentheses squared. So in this case, I just need to subtract a 3 from both sides. And then I have x minus 2 squared, there we go, equals negative 3. Now, once that's isolated, again, like before, we need to get rid of the square on that parenthesis, so we're going to take the square root of both sides. So square root, the square and the square root cancel each other, so I'm left with what's in the parentheses, x minus 2. I can go ahead and drop the parentheses, I don't really need them anymore. But then here's this guy. I know I need plus or minus. What happens when you have a square root of a negative number? Remember, that's a complex number, an imaginary number. So we pull out the I. So we have plus or minus I radical 3. And then we need to get x alone, plus 2. Now, this plus or minus, is protecting the square root of 3. It's kind of like a bodyguard. So this plus 2 that's coming over, it's trying to invade, but the plus or minus won't allow it. So the 2 goes in front of the plus or minus. And so the solution here is 2 plus or minus I radical 3. Since my radical 3 does not simplify, these would be the solutions. But now what's different about this solution that makes my graph not cross the axis? It's because it's imaginary, okay? So that means this graph has no real roots because the roots are imaginary, and that's why our graph didn't cross the x-axis, because the roots were not real. I think I've got one more to show you. So let's type this guy in GeoGebra real quick and see what happens with him. Okay, so here's the picture I got from GeoGebra. I should mention one thing. This one was not equal to 0. So in order to get this to graph, I had to add 1 to the 7 and get plus 8 when I plugged it in. But this was the graph I got, and so these are the critical points here where we're crossing the axis at -1 and -5. So I bet you can guess what's coming up. It's going to ask us a few questions. Where did we cross? We crossed at, again, -5 and -1. Did this graph have a minimum or maximum? Did it have a low point or did it have a high point? Well, this guy has a peak, so he has a high point, so we're going to call that a maximum. And what was the maximum of that point? Oh, I should have looked while I had it. Let's see. It looks like it's -3, 8. -3 and an 8. And so the next question wants us to show, why are we crossing there? So we just have to solve this for x. Same steps as before. We want to first get those parentheses squared alone. We want to isolate them. So we have a little bit more work to do on this example. First, subtract 7. Okay. So that's going to equal a -8. And then I need to get rid of this 2 out front. I can't distribute because this quantity is being squared. So since I'm wanting to distribute and multiply, to get rid of it, I would just simply divide. So x plus 3 squared equals, 2 negatives would become positive, and it would become +4. To get rid of the square, step 2 is going to be to take the square root. Okay, take square root. I'm running out of time, so I got to rush, sorry. X plus 3 equals plus or minus the square root of 4. But hey, square root of 4 is just 2, so plus or minus 2. Now I need to subtract over this 3, so x is going to equal -3 plus or minus 2. But you know what? 2 is a nice number, so actually do this. -3 plus 2, -3 minus 2. So there's the -1 and there's the -5 for my x values. Okay, so that's how we can show algebraically. Sorry I had to rush through that one, but I'm watching the clock and I'm almost out of time. But I was able to squeeze it in, so that finishes it up for us. Keep learning, have fun. I'll see you the next time, guys.